Use De Moivre's theorem to simplify the expression. Write the answer in a plus bi form. So what we have here is inside, notice the I, this is a complex number. It is written in trigonometric form or polar form, and this number is to the third power. De Moivre's theorem is a way to understand how exponents, multiplication, division, and roots correspond to this form. And it's a very simple thing. You just need to know where this 3 goes and how it applies inside. So the 2 gets the 3 as a power. So we'll get 2 cubed. In fact, let me make that 3 a different color so we can see. All right. And then the 45 degrees, the 3 is multiplied. And plus I sine 45 degrees times 3. So this is how the 3, the exponent, distributes. Now we just simplify. For example, 2 cubed is 8. 3 times 45 is 135. Plus I sine, this is also 135 degrees. Now that is the answer in trigonometric form. However, they wanted us to write the answer in a plus bi form. So we evaluate the sine and the cosine inside. Then we'll distribute the 8 from the outside. 135 degrees is a 45-degree reference angle in quadrant 2, where cosine is negative, square root of 2 over 2, plus I, and sine is positive, square root of 2 over 2. Now we distribute the 8 in, and we get negative 4 square root of 2, because the 2 cancels with the 8, leaving 4 times the negative square root of 2, and plus 4 square root of 2. And I'm going to put the I on the right so that we're actually in full A plus BI form as requested. And that's all there is to it. Find the value 1 plus I quantity to the 20th power. So you can either choose to take 1 plus I times 1 plus I times 1 plus I times 20 times and FOIL and distribute and change all your I squares to -1 in a big long process. Or you can use De Moivre's theorem, but you need to get into trigonometric form. So trigonometric form is not that bad, especially considering the alternative. 1 plus I is right here. That is, it's right 1 and it's up 1 on the I axis. So we need to find R and theta. I can see theta is 45 degrees. And the reason why I know this is because the x and the y components are equal. You could do this with tangent. Arctangent of 1 is 45 degrees. You could also just know that the slope is 1, and that happens when it's 45 degrees. Lots of ways to get that one. And R is Pythagorean Theorem. R is the square root of 1 squared plus 1 squared. That is square root of 2. So we convert first. 1 plus I to the 20th is square root of 2 times cosine 45 degrees plus I sine 45 degrees to the 20th. Okay, now where the 20 goes, it'll distribute in different ways. We'll get the square root of 2, that'll be to the 20th power, and then the 45 degrees will be just times 20 plus I sine 45 degrees times 20. Now we simplify. Square root of 2 to the 20th is the same as 2 to the 10th. And then we have cosine 45 times 2 is 900 degrees plus I sine 900 degrees. Now we actually could leave it in trigonometric form, but very commonly, and the instructions in this problem are the same as for problem 48, they want us to write in a plus bi form. When you start in this standard form and they ask you to do something to it, although we're going to a different form to make it easy, We want to end up in the same basic form they asked. That'd be like asking a question in German, give the answer in German. Even if you have to translate to English in your head to find the answer, fine. Give it appropriate answer for the question. 2 to the 10th. That's 1024. 1024. And what is cosine 900 degrees? So we have to figure out the reference angle for 900 degrees. So we just add up 360 a couple times. 360 plus 360, that would be 720. And then 900 minus 720, that would be 180. Great, so the reference angle, this is a 180 degrees. So cosine 180 degrees plus I sine 180 degrees. So if you subtract 360 degrees from an angle, you get a coterminal angle. That angle, the sine and cosine of that angle will be the same value. So you can change from 900 to subtract 360 and then subtract 360. Finally we get to 180. Now this is not too bad to evaluate. It's useful sometimes to go back to 180's here, and that point is negative 1, 0. And this is cosine sine. Cosine is negative 1, sine is 0. So we have 1024, cosine is negative 1, plus I times 0. That is all just negative 1024. Get that right? 1024. That's the answer. Great. Find the indicated roots. Write the answer in trigonometric form. So we want to find the cube roots of 125 times cosine 312 degrees plus I sine 312 degrees. Now for a change, I'm going to write this in a little bit different notation. It's still the trigonometric form, but some books adopt this. This would be 125 and then CIS parenthesis 312 degrees. This is a shorthand. The C is for cosine, I is for the I, and the S for sine. So that's cosine plus I sine. It'll make it a little bit easier. Alright, so this is Z, complex number. We want the cube roots of Z. Well, the first cube roots, so there are 3 total. There's a couple of things that we can do to make this a little bit easier. So one pattern is, if you're looking for cube roots, you better get 3 answers. If you're looking for square roots, you better find 2 answers. Fourth roots, find 4 answers. The first one is pretty easy with the Mavericks Theorem. So the first one, I'm going to call this Z sub 1. Actually, I don't want to use Z because this isn't Z. Let's call it W sub 1. W sub 1. So if you take your 125 and your CIS 312 degrees, the cube root, Z to the 1/3 power. We're doing just a regular power, but it's a fraction power. So that 1/3 is going to be raising the 125, and it's going to be multiplying by the 312. Nothing fancy here. This is a basic, straightforward de Moivre's theorem with an exponent. The exponent applies to the modulus, absolute value of the complex number, and the angle 312 degrees we multiply by the exponent. In this case, multiply by 1/3, it'll be like dividing by 3. So we simplify this. This is going to be 5 CIS 104 degrees. That's our first root. Now that's not too hard to do. In fact, let's take a look at this. Looking at this one will help us find the remaining ones. So where is this? 104 degrees. It's out here somewhere. There's the dot right there. And that's out 5. Okay, the key to cube roots in the complex plane is they will be equally spaced. So there's another one here. And there's another one here. And they are equally spaced. In other words, 360 degrees dividing by 3 for cube roots is 120 degrees. They are 120 degrees apart of each other. Cube roots will always be equally spaced. Fourth roots, all the roots are equally spaced from each other. So if you have fourth roots, there'll be four numbers and they're all equally spaced. So once we know that they're equally spaced and we're looking for cube roots, we can just take our 360 degrees, the full circle, and divide by 3 and find out the spacing, 120 degrees. So now for our second root, it is 5CIS, and we have the 104, add 120 degrees to that. So that is 5CIS of 224 degrees. And W3 will be 120 degrees more than this one. So 5CIS, add another 120 degrees, and we get 344 degrees. Now some books don't want you to go over 180 degrees for whatever reasons, and so we would have to subtract 360 degrees from our previous two answers. And this, you'll know if this is the case for your book or not. So we would get W2 is 5CIS. Subtract 224, subtract 360 from that, and it's negative 136. And W3, 5CIS, and subtract 360 from 344, and it's negative 16 degrees. Same result if you convert these all to the A plus BI form. Obviously same answer. And the first one's the same no matter what, regardless of your book. Well, usually, if you have the correct trigonometric form to begin with. So there are a lot of fancy formulas in books, possibly in the book you're using. However, if you understand the concept that these are equally spaced, all the roots are equally spaced, and if you're doing a fifth roots, then you 360 divided by 5, you get the equal spacing. The first root is trivial to find because you have your initial complex number, and then you do the power and the division, and you get the simple first root. Then the equal spacing to get the rest. Okay, excellent. Find the fourth roots of 16 times cosine 260 degrees plus I sine 260 degrees. For space reasons, I'm going to convert this to the CIS notation. Essentially, CIS stands for cosine plus I sine. It's all of this stuff condensed into this notation. They mean the same thing. Alright, fourth roots. There are four answers. Because it's fourth roots. So if I call z this first number, then the first root, W1, will be based on our z. So you find the first answer, the first root, by working with the original number. Fourth root means that we're going to have a 1/4 power on the 16 and a divide by 4 on the argument. This gives us W1 equals 2, 4th root of 16, CIS of 65 degrees. Alright, so let's locate that one. 65 degrees out there, length 2. This is our first number. Now the key to roots in the complex plane, if there are fourth roots, they will be equally spaced. Now a full circle is 360 degrees, and if we have fourth roots we have to divide by 4 and we get 90 degrees. This is the equal spacing. So if I move around 90 degrees from this one, I will, in the same modulus, I will find the next number. So just visually, that's the next, that's the third one, and that's the fourth one. These are the four complex fourth roots of 16 cosine 260 plus I sine 260. They're equally spaced and they should be the same distance away. Now, we have our first one, W1. So W2 is also 2, CIS, with just 90 degrees more than 65 is 155. That would be this one. The third root would be also 2, CIS, and another 90 degrees. Add another 90 is 245. And W4 would be 2CIS, another 90 degrees. 245 plus 90 is 335 degrees. So these are the fourth roots. Now, depending on your book, some books that I've taught out of require you to only go up to 180 degrees. So if you're more than 180, like our 245, you subtract the 360. So you go backwards. In other words, some books want you to measure from the x-axis either clockwise or counterclockwise to get to the angles. That's just a book's choice. So in that case, W1 would be the same, 65 degrees. W2 would be the same, because that's 155 is not more than 60 or 180 yet. W3, if you subtract 245 minus 360, you get negative 115 degrees. And W4, 2CIS, if you take 335 minus 360, you get negative 25 degrees. So this is, I mean, these mean the same thing as far as if you convert these back to the A plus BI form, it's the exact same number. And also remember what CIS stands for. It's cosine negative 115 degrees plus I sine negative 115 degrees. That's what this notation stands for. Okay, great. Solve the equation. Write the answer in A plus BI form. Okay, so we have x cubed equals negative 8i. And that's just subtracting the 8i to the right. So x are the cube roots. Of negative 8i. So we need to find the cube roots. There are three answers to an x cubed equation. They're not always real, but we're in the complex plane, so we can find all three answers of an x cubed equation. This is the fundamental theorem of algebra. If it's an x cubed, there are three answers. Okay, so we need to find the cube roots of negative 8i. They could have just asked for that, but sometimes these questions are phrased in terms of a solve equation. So we'll start off with z equaling negative 8i, location down, negative 8. So that would be angle 270 degrees, and r equals 8. So we can convert z into 8 CIS 270 degrees. Don't forget what CIS stands for. It is cosine of 270 degrees plus I sine of 270 degrees. It's just a quicker notation. It means the exact same thing. Alright, so we need to find the roots. So the solutions, there are three. X1 is, we start off with the original complex number. This would be negative 8i in trigonometric form. That is 8 CIS 270 degrees. And for cube roots, we get a 1/3 power on the 8, and we divide by 3 on the 270, and we get 2 CIS 90 degrees. That is our first answer. Now, equal spacing. Cube roots are equally spaced. Our first one's at 90 degrees. There are three of these because it's a cube root. If I do 360 degrees divided by 3, I get 120 degrees. They are spaced apart by 120 degrees. So my second solution will be 2 CIS. 90 plus 120 is 210. So what has happened here is my first root is 90, and then I add 120 degrees, and I get 210 degrees. Our third solution is also 2. They all the roots have the same modulus, or the number out in front in trigonometric form, the same absolute value of this complex number. 2 CIS, and 210 plus 120 is 330. So we go another 120 degrees, and what we have are three answers. One's straight up at 90, one's at 210, one's at 330, and these numbers are equally spaced. They each are differing by 120 degrees. Now it is critical that you start by finding the first answer, then go to the equal spacing to find the rest. The first answer is easy to get. You take your initial complex number that you're trying to find the roots of. If it's a cube root, the modulus, you do 1/3 power. The argument, you divide by 3, simplify. First root is easy. The next ones are also, because it's just an equal spacing issue. So we're essentially done, except for our answers are not in a plus bi form. So now we convert. So x1 equaling 2 CIS 90 degrees is really 2 times cosine 90 degrees plus I, it's not a looking plus, let me make that better, plus I sine 90 degrees. And this simplifies to be 2 times cosine is 0 plus I and sine is 1. That is just 2I. First answer. Okay, second answer. 2 CIS 210 degrees. Third quadrant, reference angle 30. So we can go to 2 cosine of 30. Square root of 3 over 2, negative third quadrant. Negative square root of 3 over 2. And then plus I, and sine is negative 1/2. So this is negative square root of 3 minus I. Second answer. Third answer, 2 CIS 330. This is also a 30-degree reference angle. Now it's in quadrant 4 where cosine is positive, so cosine will be positive square root of 3 over 2. Sine is still negative 1/2. So that works out to be square root of 3 minus I. Okay, this completes how to find the solution of this equation. And we've rewritten them in a plus bi form. Great. Solve the equation. Express your answer in trigonometric form. So if I just start solving for x, I will get x to the 5th equals 6. Alright, so what we're looking for are the 5th roots of z equals 6. Now z equals 6 is in trigonometric form 6 CIS 0 degrees. This stands for 6 cosine 0 degrees plus I sine 0 degrees. This is because 6 is just to the right on the x-axis. So that's a 0-degree angle, and it's out 6 modulus. So here was 6 and 0. This notation is a little bit easier to write. It takes a lot less room, and so I'm going to stick to this for this presentation, but just know what it means. Alright, so 5th roots. The nature of 5th roots. Let's get the first root. So x sub 1. There will be 5 answers. X sub 1. If I take our initial answer, a 5th root will be a 1/5 power of 6 and a divide by 5 on the angle. And I just get 6 to the 1/5 CIS 0 degrees. That's our first answer. Okay, next one. Now we utilize equal spacing. All 5th roots are equally spaced. In other words, our whole circle, 360 degrees, if I divide by 5, I get 72 degrees. So each answer, each 5th root will be 72 degrees difference from the other ones in trigonometric form. So x2 will just be 6 to the 1/5 CIS of, if I add 72 to 0, I get 72 degrees. X3 will be 6 to the 1/5. CIS, if I add another 72, I get 144 degrees. X4 will be 6 to the 1/5. CIS, adding another 72 degrees gets us to 216. And X5, our last answer, is 6 to the 1/5. CIS, and adding another 72 degrees gets us to 288 degrees. So what we're looking at, oh, I forgot the first one. Oh, they're all done. We have 5 answers. And x to the 5th problem, polynomial, will have 5 answers. 1, 2, 3, 4, 5. Some books require you to subtract 360 degrees from anything over 180. So these two would be negative answers in those books. That's an easy fix. And other books require you to not write CIS, although it's so convenient, but to actually write, for example, this one would be cosine 288 degrees plus I sine 288 degrees, very much like this notation. But this is very fast and easy, and the equal spacing saves you from having to work out whatever crazy formula version they have for this concept. All right, that completes this problem.